Hey everyone, so this is an updated extra help video for how to do the mole-to-mole stoichiometry problems. So the important part is that we are reading problems carefully. So that's our first step when we approach any of these problems. We want to look at it and we want to identify what info is given and what substance are we solving for. So what are the things that we have? What are the things that we want to have at the end of our equation? If your given is in grams, so if I say I have 24 grams of sodium, use that substance's molar mass to convert it to moles. So anytime you're given grams, convert it into moles. Only moles can go on our BCA table. So that step 4 is write the given number of moles in the appropriate space within the BCA table, which we'll get to in a moment. Use the mole ratio from the balanced chemical equation. So these are how the things relate to each other in the problem that we're working in. These are always going to change. So it always depends on what chemical equation you're working with and also how those things relate to each other. And then we're going to use that mole ratio to solve for the rest of the change in that BCA table. And that'll lead us to our answer. And then we're going to record our answer with the correct units attached. So what exactly goes on our BCA table? Well, on our BCA table, we have our reactants. Our reactants are the things before the arrow begins. So in your before column, if you aren't given anything, you can just assume that it's excess. Otherwise, place the starting amounts there. So if you're given a starting amount, put it here. What you use up, subtract. So anything that happens in the change on this side of our chemical equation, we're going to be subtracting. And whatever's down here is what you're left with after the reaction has completed. Now the products. This is the easy one. This number should always be 0. You don't start with anything. If all I've done is gather bread and cheese, I have not made any grilled cheese sandwiches. Therefore, I have no product, nothing made yet. So what you're making from the reaction is what goes here, what goes in this change column. And this is going to be an addition. Let's actually make that even an addition sign so we make it a little easier to read. And what you have after the reaction is what will be made. So the final number of things. So most often these numbers are going to be the same. Very rarely would you ever find a problem where we're giving you a starting amount to add to this. Usually it's 0 plus whatever you've made equals this. And here's why we do this. So here's a really simple look at this. So what we have to pay attention to are these big numbers out front. These are the coefficients. If there's no number there, we can assume there's 1. So 2 hydrogens, here's my 2 hydrogen molecules here. So this is H2, so I have 2 H2s, are added to 1 O2, so I have an O2 drawn here, will equal 2 H2Os. So what's happening is these are splitting apart and these hydrogens are kind of attaching themselves onto each one. So this is its simplest ratio. This is for every 2 hydrogen molecules I have, it's going to react with 1 oxygen molecule, and I'm going to get 2 water molecules on the other end. This is the very, very simple way to think about this. It's how everything fits together. So we can look at this. For every 2 waters, I needed 2 hydrogen. For every 1 oxygen, I needed 2 waters. For every 2 waters I made, I needed 1 oxygen. For every 2 hydrogens I used up, I also used up 1 oxygen. Everything relates to each other. Let's look at that using a different value. Let's use a dozen because it works the same way, because this is just how things relate to each other. So if I have 2 dozen hydrogen H2, so H2 is diatomic, so it's always going to be attached to itself. So if I have 2 dozen H2s and it reacts with 1 dozen O2s, I'm going to end up with 2 dozen waters. So look at down here. If I have 2 dozen H2s, I need 1 dozen O2. If I have 1 dozen O2, I make 2 dozen H2Os. I don't want to get too hung up in this. All we're trying to say is, for every 2 of these, I need 1 of these. Because we're going to use the term mole And this is how we actually use it, because moles are remembering. Those are a nice simplified way of saying an amount. And 1 mole is equal to 6.02 times 10 to the 23rd number of atoms. So if I have 2 moles of H2, then I have 1 mole of oxygen to react with. If I have 2 moles of H2O, I used 2 moles of H2. If I use up all the oxygen, the 1 mole of oxygen, I also used up 2 moles of H2. So I want you to think about these. We use these moles as a way to count these huge number of atoms, because in 1 little teaspoon, I have more atoms than there are probably cups on Earth. There are so many of them around. So we have to talk about things in these huge numbers, and we simplify it by using the mole. So let's take a look at some of these problems. What are you really being asked to do? So how many moles of sodium hydroxide will be produced from 4 moles of sodium in the following reaction? So I read the problem carefully. Now we're going to identify what info is given and what substance we need to solve for. So what's given? Well, I have 4 moles of sodium. And what am I solving for? How many moles of sodium hydroxide? I like to circle what I'm looking for and underline what I have. It's just a system that works for me. So what's my next part? If your given is in grams, use that substance's molar mass. So let's look. We're given it in moles. I can just move on to the next step. Write the given number of moles in the appropriate space on the BCA table. So will be produced from 4 moles of sodium. So 4 moles of sodium are reacting. So 4.0 moles are going to react. Use the mole ratio from the balanced chemical equation to fill in the change row for what you need to solve for. Well, I said I wanted to find out moles of sodium hydroxide, so I'm trying to find this column. I know that I didn't start with anything because it's before this arrow. Okay, we can assume that I had excess of this stuff from what we talked about earlier. This is going to be subtracted. Whatever is here is going to be added. Okay, these are all things that I know just from reading the equation and also what I know about chemical reactions. Okay, so now I have to use this mole ratio. So I have 4 moles of Na. I'm going to put that out front and over 1 like I do for any other conversion. And I'm going to use that balanced chemical equation up top to figure this out. So for every 2 NAs, so I'm taking that number right from here, I'm going to make 2 NaOHs. So 4 times 2 is 8, divided by 2 is 4. So I'm still going to have 4 moles of NaOH. So my answer, 4 moles of NaOH. So nice and simple. It's just right and direct. So that way we have a good quick answer here. Okay, so that's our first one that we did. Now you can also notice this coefficient up here is the same as this one. So it's 1 to 1. So I could just write that number right in there and go for a little shortcut if I want to. However, I don't advise it. I like to check my work and make sure that Na cancels with Na. I'm left with NaOH, 4 moles of NaOH, and that's how I know that I'll be left with the correct answer on the other side. Let's look at another one. We use the same chemical equation. We're just going to take a different approach. So let's, again, read the problem carefully. So that's our first step. So how many moles of hydrogen will be produced from 8 moles of sodium in the following reaction? So I'm identifying what info I have. So the first thing I have is 8 moles of sodium. And I'm solving for moles of hydrogen. So moles of hydrogen gas. So I can put my 8 moles here. It's not given to me in grams, so I don't need to do anything there with grams. So I have 8 moles of sodium. And in the following reaction, and I'm solving for this. So this is what I'm looking for, the hydrogens that are here. How many will I make? So this column. So Na, I can assume I have enough because I didn't give you any number. We know we don't have any of this because we haven't made anything yet. We want to use all of this stuff up, right? So we're going to use up all that Na that we have here. So I don't want to have any of that 8 left. Over here for the H2, we have to now figure out what this is. So we have 8 moles of Na over 1. And for every 2 Na, I have 1 H2. So again, using this 1 that's kind of here for the H2 and our coefficient here for the Na. So I'm trying to cancel out those NAs, be left with that. So 8 times 1 divided by 2, it's 4. So I'm going to have 4 in this column. It's always going to be added from here, so I'm going to add and have 4. This right here ends up being my answer. So answer is 4 moles of H2. All right, let's try this again. And now I'd like you to try to pause the video, try this on your own, and then walk through it with me in a second, okay? So pause here. And I'm assuming that you've now tried to answer it on your own and that we'll walk through it together. So the first thing is read the problem carefully. How many moles of water will react with sodium to form 5 moles of hydrogen in the following reaction? So I'm given 5 moles of hydrogen. I'm looking for moles of water. All right. So I have 5 moles of H2. I'm just putting the unit here just to keep it here. I know that's going to be added from nothing, right? Because I didn't make anything before after the arrow yet. And I'm going to be left with 5 moles here at the end of this reaction. I'm trying to solve for here. I didn't give you anything initially, so we can assume that there's excess. I just want to know how many are going to actually react with this water. So I have 5 moles of H2. For every 1 mole of H2, I react with 2, or I get 2 H2Os. So we have double, right? 5 times 2 divided by 1. So this would be 10. So this would be 10. So that would be 10 moles of H2O. So again, these numbers coming from my equation up top here, that's how everything is going to relate to each other. And just looking at what columns I can fill out and the information I can fill out. I think the biggest part of where people go wrong is not going through the problem and trying to solve it by looking carefully at what is being given and what you're being asked to solve for. So let's take a look at a little bit more of a complex one. Again, try to pause here, try to solve it on your own. I'm going to assume that you've unpaused your video and now you're going to try to correct your answer with me. Okay, so how many moles of oxygen gas are needed to react with 2.5 moles of C3H8 in the following reaction? So I'm given 2.5 moles of C3H8. I'm looking for moles of oxygen gas. So I want to find these. I want to find those boxes. Being given this box right here. So we can assume we're going to start with excess or 2.5. I guess you could start with 2.5 here too, because I want to use all of it up. So 2.5 minus 2.5 is 0. However you want to work that out. This one's definitely going to be excess because I'm asking just how many do I need in order to get there. So let's look at how these things relate to each other. So I have 2.5 moles of C3H8. And for every one, so this is no coefficient out front, so we can imagine there's a 1 there. 1 C3H8, and then we have 5 oxygens, so 5 O2s. And what do we get? So I prefer to not do math in my head, so I'm going to toss this into my calculator, which is off screen. 2.5 times 5, which equals 12.5 moles of O2, which that would be my answer. So that would be the 12.5 there. Be subtracting that out because it would be used up during that reaction. Okay, let's try another one. All right, so how many moles of NH3 will form from 5.25 moles of N2 gas in the following equation? So again, pause here. I'll assume that you've unpaused the video to try this on your own. So we're looking for moles of NH3. I'm given moles of N2. So I can put these down here. So I got 5.25 moles. I'm going to use up all of those 5.25 moles. I have nothing. I'm trying to look at how many would be formed here. So solving for this box. We know there's nothing here. So what's added, what's made? So I have 5.25 moles of N2. Going for my standard conversions, right? Using what I have for the relationships here. For every 1 N2, I make 2 NH3s. 5.25 times 2, which ends up being 1050. And that would be moles of NH3. So I'm making 10.5 moles of NH3. Good. So, and you can even kind of check this out. For every one of these, I'm going to make 2. So this should double every time that I do that. So you should see twice as much on the other side. So even if you're doing a quick estimation, I should know that on the other side, I should see that. And again, that's all because of how these things relate to each other. That's why we balance these equations in the first place. Let's look at another example here. I think this is the last one. So how many moles of potassium chloride are produced when 4.75 moles of chloride react in the following equation? Pause here and try to get this one, okay? Great. So how many moles of KCl? We are given this. So again, given this 4.75, I'm going to subtract all of this 4.75, be left with nothing because I'm going to use all of it. I got to use all of it to figure out how much it can make, right? You don't start with anything that you haven't made yet. And whatever this is what we're going to make. So I have 4.75 moles of Cl2. And this is a step. Don't skip this step, right? Try to always do this, write out the work. It's just a way to make sure that you have it correct all the way through every single time. The more ways that you can check if you're correct, the more you'll know that you're right on the test. So we have 4.75 moles of Cl2. We go up to our equation. I have 1 Cl2 for every 2 KCl and 4.75 4.75 times 2. I keep hitting my my key. Times 2, which equals 9.5. And that is moles of KCl. And that is my answer. So I'm identifying what my answer is too. Sometimes people lose points because they actually don't know what they're solving for. They solve for everything and they never actually tell me what the answer is. So make sure that you are telling me that you know what the answer is at the end of these equations. So just as a recap, the important steps are: read the problem carefully, identify what info is given and what substance you need to solve for. If your given is in grams, we have to convert it. All of these problems that we looked at today, you're given in moles. Write the given number of moles in the appropriate space on the table. Use the mole ratio to convert it, and then record your answer with the correct units attached. And that's it. That's all I want for that first chunk. So being able to just solve for those moles. And the key is because next time I'm going to be giving you grams. You're going to have to convert grams to moles first and then still go through this whole process. So it's important that we really understand how this process all unfolds together. All right, I'll talk to you later. Have a great day, everybody.